All right, can everyone see my screen okay?
Yeah, we can see your screen.
Okay, beautiful. I want to try. Sorry, just getting things settled on my Zoom. Okay, can we do like a raising hands exercise? Can everyone look down on the bottom Zoom bar and raise your hand? Yeah, I want to use this a little bit in the presentation. So, okay, I'm still seeing quite a few haven't raised a hand yet. Who else can give me a hand? Okay, we got almost everyone. 25 out of 38. That's not bad. Okay. Now can you like take your hands down? Can you like unraise your hand? Oh, nice.
Perfect.
Okay. Okay. This is great. I just want to do a little bit of so I'm doing the intro to the Internet Computer Protocol. We can go as deep as you want, but I really wanted to give a kind of a higher level overview of what's the Internet Computer Protocol and why is it arguably the greatest blockchain in existence. And then we could talk a little bit about uh, generally how the Internet Computer blockchain works, how it compares to other blockchains, if we want to go there, Avalanche, Solana, Ethereum, and then a little bit about the technical side behind NFTs. I'd like for this to be pretty interactive. So if you have questions, feel free to drop them in the chat. I'll answer them as we go along, but if it just doesn't fit, then we'll get them at the end. So we will do Q&A at the end. To start, I wanted to take everyone to a really good resource called ICP. Whoops, typed it wrong. ICP Guide. So I'll drop it in the chat as well. Anyone can go there. The ICP Guide is a resource I created to help people understand what the Internet Computer is. And I have this What is the Internet Computer article that goes through, I mean, probably more information than you would ever want to know about the Internet Computer. This is a high level overview, but I think it helps for, bootcamp participants because it's important to understand what blockchain you're building on. So to start, I'm just going to kind of breeze through this, and you can always come back and read more. So let's talk a little bit about the history of the Internet Computer. Started by Dominic Williams and the Definity Foundation in October 2016. So just that by itself is pretty crazy. You know, we're in 2022, and this was October 2016. So been under development for a long time. They raised a bunch of money. They're extremely well funded from big people like Andreessen Horowitz and Polychain Capital. They did do an airdrop. They raised some more money. Finally started to release some code 2019, 2020, 2020, all the way through 2020. And then the Mercury launch, this was May 2021. This was the official mainnet launch. So as of May 2021, we have the ICP token. We have a functional, production-ready mainnet blockchain. So been a long time coming. That's almost 5 years of development. The Definity Foundation, like I said, well-funded, 200 plus employees, some very well-known cryptographers, PhD computer scientists, et cetera. So this is not some scam coin. This is not some just side blockchain. Like, this is some serious cryptography all packaged into a really nice blockchain environment. So let's look at some Internet Computer components. As a developer, you will be essentially, your code will be on a canister. So you can DFX deploy, and you can spin up a canister and all your code will live on your canister. A canister is like a server. You could think of it that way. Every time you deploy to the Internet Computer, you actually, by default, get replication throughout your subnet. And so subnet is a group of nodes. Subnets, I think the default right now is 13 nodes per subnet. And so when you deploy a canister, you by default get that 13x replication across all the nodes in the subnet. When you read from the internet computer, reads are very fast. You just basically find the nearest node and then you read the data. When you actually push updates, it takes a little bit longer because the 13 nodes all have to come to consensus. Consensus means you're pushing up data to one of the nodes and then it has to propagate through in a safe way so that everyone has the data. And so generally writes take around 2 seconds and reads are sub-second. So reads are very, very fast. So really nice on the internet computer, you get that default replication. Like I was talking about, you get fast finalization times. If you compare that to like Ethereum, I mean, Ethereum is in minutes, finalization probably like 15 minutes, I think, ish. And so you can't really do web speed stuff on Ethereum. So the internet computer is really nice. Also, only having 13 nodes in a subnet means, like I said, faster consensus, but also storage costs are much less. So on Ethereum to store data, it's like, I don't know, $1 million per gigabyte or something like that. Solana, probably hundreds of thousands of dollars per gigabyte. And internet computer is just $5 per gigabyte per year. So storage is extremely affordable compared to other blockchains. And so on the internet computer, you get everything is 100% on chain. And so 100% on chain means your front ends are served from on chain and your images are stored on chain and your videos are stored on chain and basically everything is on chain. And this isn't true for basically any other blockchain. I think, let's see, for Ethereum and even Solana, I think most people are storing large amounts of data on IPFS, which is interplanetary file storage, like a peer-to-peer storage system. And then also storing on Arweave, which is again, a nice kind of peer-to-peer storage. Those aren't super decentralized. I think we still have a pretty solid percentage of, AWS servers on those technology platforms, but still just the simplicity of having everything on the internet computer is really nice. Let's see, how does the IC know that the read data is accurate and true? That's a really good question. So generally, if you just do a normal read, then you don't have any guarantees in terms of like where you read the data from or that you didn't get intercepted by a middleman. They have something called certified variables. And you also can just, instead of doing a query, you can just do an update. And then you get the guarantees as well. And so for like reading data being accurate and true, certified variables, or just do an update call instead. Or I think what some people are doing is they're doing a read, a quick read, display it, and in the background do an update as well, because then you get the verifiable read. And so you do the initial read and then basically just lazy load the subsequent longer update call, and then you get better data, at least accurate and true certifications. So that's subnets, that's nodes, that's canisters. The NNS is I think this is wrong. I think it's the network nervous system. This is embarrassing. It's been this way for like months. Okay, it's the network nervous system, not the nervous network system. That actually makes it sound pretty funny. Okay, system of neurons. This is how the protocol is updated. So basically right now, no one has access to just go and throw up new code and update the protocol. So the way it works is there's a network nervous system, and it's basically a canister. Let's say it's a voting canister, and everyone buys ICP from an exchange, stakes it into the network nervous system app, the NNS app. And by staking it, you get voting power. And then you can submit proposals. Proposals come in, you vote on the proposals, and then if the proposal passes, it essentially gets pushed out and It's really hard to focus. You guys are hilarious in the comments right now. This is like the most glorious moment of the presentation. So, okay, so the NNS. Hold on, let me take a drink. You guys can continue to banter in the chat. Okay. So basically, it's like a GitHub pull request. So if you're going to make a change to the code, you do a PR into GitHub, and then you actually submit a proposal. I think when you submit a proposal, there's like WASM code or something that's submitted with the proposal. And you can go and you can look at GitHub, you can look at all the changes. There's like a proposal summary, and then everyone votes. And there are certain voting criteria that decides when do you push something out and when do you not, based on whether it's accepted or rejected. If it's accepted, I believe that the upgrade just happens automatically. So the NNS canister then pushes out the update to all the other nodes, and the entire network gets updated all at the same time. This kind of process is really good because it means no one can actually control the protocol. You know, it's a community governed protocol. There are some downsides, like what if there's a bug in the internet computer protocol and you need to fix it, but you can't fix it because you actually have to vote on it. But if you're too explicit about the bug when you're pushing the update out, you're essentially saying, hey, here's a glaring flaw in our system, and here's a bunch of detail on how we fixed it, but we can't do anything until we voted on everything and we push the update out. And so I think there are some cases where you can do like a hot fix, or you can do like a quick vote or something like that. I don't know. It's not a extremely I guess what I'm trying to say is there are some interesting things to discuss there, and I'm not exactly sure how they all play out, but I'm sure there are contingency plans in a security case. Does it mean the IC will never have a fork? The internet computer is, I think at this point, almost all open source. It might be completely open source, meaning someone could just take the ICP ledger, they could copy it all, and they could just completely fork the code. They could get new node providers, they could get new boundary nodes, and then they could spin up install the new, we'll call it ICP2, on all the node providers, set up their boundary nodes, set up all their configurations, and paste in the ledger from the existing one, and you have a fully forked internet computer. So there isn't really anything that's keeping someone from just taking all the code, getting new independent node providers, setting up your own boundary nodes, and then handling, I don't know, maybe some other things that need to happen, but you could definitely fork the internet computer. There was a group early on that was trying to do a reboot, but didn't really get any traction. People that were upset about the launch. Yeah, okay, so we've talked about the network nervous system in great detail. Neurons, proposals, votes. Okay, internet computer protocol, or ICP, is a utility token. Utility token you can buy at any exchange, Coinbase, Binance. You can stake it to get governance. You can use it to buy NFTs. You can, I mean, it's just like the token on the internet computer. Then there's also cycles. You've probably been aware of cycles because you need cycles in a wallet to fund creation of canisters. And so cycles is pegged to something called SDR or XDR. It's like an international basket of currencies. And ICP price could go way up, but cycles is a stable coin, I would say. And so price is consistent over time. So that's cycles. You have to have cycles to fund a canister. Canister, basically you put, I don't know, X trillion cycles in a canister, and then it goes down over time, and then you have to continue to top it up. So you can make sure that you don't run below some threshold. There usually is like a freezing threshold, like 1.5 trillion cycles or something like that, at which point, and this might be configurable, but then you can't actually hit the canister anymore. Like everything's just going to fail, and then cycles slowly deplete. So you got to keep canisters topped up. Okay, lots of benefits to the internet computer. We've kind of talked about what it is and how it works and how it compares to other blockchains. There are some solid benefits to the internet computer. Community ownership, like I talked about, owning ICP, staking it in the NNS, voting on proposals. Improved security. I think the gold standard blockchain for security is probably Ethereum. Thousands of nodes, decentralized. The only problem is because you have so much security, it's really expensive and it's really slow. And so you have some trade-offs there. On the internet computer, you only have 13 nodes in a subnet, so much fewer than thousands, but you do still have geographically distributed nodes. You do still have really good security through the cryptography on the internet computer. Security isn't all the way there yet. For example, right now, a node provider could go to one of their nodes and they could just peek inside and they could see what they're hosting. And there's nothing preventing them from doing that right now. So node providers are trusted entities at this point. And really the only way to hack it would be to collude with other node providers. So if all the node providers got together and for some reason decided they wanted to hack some canister, they probably could do it right now because they just have access to canister code. That will be improved over time, things like secure enclaves. So, preventing node providers from actually peeking into the machine, as well as maybe node shuffling. So you only host a specific node for a certain amount of time, maybe hours, maybe days, and then it moves to a different place. And so subnet configurations are always changing. So lots of things coming down the pipeline in terms of like improved security. Easier to use for developers. I'm not a true developer. I was a data scientist for 5 years. I've hacked around on the internet computer. I've deployed applications, and I do tons of stuff on the Python agent. So making canister calls all the time. But the deploy process is really simple for developers. You have your repo, you have all your config files, your canister files and other things, and you just DFX deploy and it just deploys. You don't have to worry about setting up your VPC or your firewalls or other kinds of things like that. So generally, it's a simpler experience, I think. And you can be the judge of that this week as you dive in deeper. Initially, might not seem simpler, but once you get the hang of things, really nice. Let's see, anything else I need to... Yeah, GitHub static pages, hard to beat that, although you can't have a full-blown application on GitHub static pages. Okay. If I create a website on the IC, will it burn the cycles of people accessing the website? Yes. So the internet computer has a reverse gas model. Reverse gas model means, well, let's talk about what happens on Ethereum. On Ethereum, you go to a website and you want to do something, you need to connect your wallet, you need to have ETH in your wallet, and then you're going to actually sign a transaction and you're going to pay gas, and then it's going to happen. So I got some NFTs on Ethereum. It was a play to earn game. I wanted to stake. It was this little orc guy. I wanted to stake my orc because then he was going to give me Zug token. And I wanted Zug token because you can do stuff with Zug. So in order to stake him, I bought him on OpenSea, had to pay gas. Then I went to this website and they actually have their own Polygon bridge. Polygon bridge meaning essentially I'm taking my ETH orc and then I'm going to convert it into a Polygon orc, and then I can do stuff on Polygon. But every time I do something, every time I stake him or click or interact in any way, claim Zug, I have to pay token in order to pay the gas, so to facilitate the transaction. Conversely, on the internet computer, it's just like the internet. So if I'm going to spin up a website on Web 2 tech, I'm going to go to AWS, I'm going to buy a server, I'm going to set up a database, I'm going to set up my application, and I'm paying all of those costs. And so the only way that that's sustainable is if I have some sort of business model or some way to fund the resources I'm providing. So similarly on the internet computer, you have cycles, and cycles power the compute in your canister, and you're the one that's responsible to keep that topped up, because anyone pinging that canister depletes cycles. So someone could even like DDoS your canister if they wanted, like spin up 1,000 IP addresses and just hit methods on your canister over and over and over, and it's going to deplete your cycles. Read. So queries don't burn that many cycles. They're really, really fast. In fact, if you compare data in and data out costs between the internet computer and AWS, data in for AWS is free. Basically, they want AWS wants your data. They want all your data. Like throw it on AWS, and it's free to get data in. And then they upcharge you on the data out, and so it costs more to get your data out. On the internet computer, it costs more to put data in because you have a subnet, you have 13 nodes on the subnet, and you have to get data everywhere. And so it's a little bit more expensive to get data in, but it's really inexpensive to get data out. So it's cheaper on the internet computer to get data out than it is on AWS. So for high read applications, I think the internet computer would fare pretty well. Let's see, where was I going with? Oh yeah, so basically when you have a canister, yes, cycles will be burned and you'll need to top them up. So right now, so I work at Tonic Labs. I'm Chief Product Officer at Tonic Labs. We created the NFT marketplace entrepot.app, and we have like 65 plus NFT canisters at this point. And so to keep everything topped up, we just have a little auto top up function that runs every so often. It checks cycles on all of our canisters, and if anything drops below a certain threshold, it sends ICP, converts cycles, and tops up. So that's what we've had to do, because if cycles drop too low, then things stop working, and when things stop working, people get mad, and we get tons of support requests. So we have kind of this auto top-up solution now working where it's running pretty well, although a bit expensive. We need to find a way to make it a little bit cheaper to run, but yeah, going well. Okay, a couple questions. I've noticed cycles wallet slowly decreases even when it's not funding another canister. Why is that? I don't think I know the answer to that, although the internet computer is interesting because you do pay for storage over time. And so even if your canister is not doing anything, you're still going to pay for storage. On the cycles wallet side, I don't know if cycles wallet by itself, if you have to pay for storage in some instance. That's an interesting question. Let's see, can we totally mess some rival project cycles by putting some scraping program on it nonstop? Hypothetically, of course. Haha. Yes, but hard to do because reads just don't do that much. Like you could hit a canister 20 times a second, and it's just not going to impact cycles that much. Reads are really, really efficient. So you need to do some kind of update, but like, what are you going to even update on a canister? And are you even going to have permission to do that on the canister? But yeah, I mean, you could do something like that, but I don't know. It's just, it's not that expensive to host things on the internet computer. So it probably wouldn't even work that well. Way more effort than would be worth it. How come also the internet computer does implement some DDoS protection? I think there's something like you can hit a single IP address can hit a canister like 20 times a second or something like that. But anything past that, you start getting failed requests or something like that. I mean, this is something I've heard, but I'm not sure if that's exactly right. How come some functions are crazy slow on the IC? So every single update takes 2 seconds, basically. And so imagine if you need to like reserve an NFT and make an ICP transfer and transfer the NFT and update the ownership. I mean, if you start like tagging all these things together, I mean, you've probably noticed if you've purchased NFTs on Entrepot that it takes maybe like 15 seconds to actually purchase, and that's because you have a string of updates that all need to happen in succession, and so then it just kind of takes a while. It's also partly because ICP transactions aren't that friendly right now. Really easy to just hit the ledger canister and make a transfer, and you get back a block index. But to actually verify that the transaction has occurred is a pain right now. There are two different ways to do it, and both of them are kind of annoying. And so it's partly that ICP is new and there aren't really streamlined ways to do things in some cases. And it's partly that if you have to do multiple update calls, it's just gonna take a while. Let's see. Can you top up someone's canister with cycles? Yes. In fact, anyone can top up any canister with cycles whenever you want. You basically just have a canister and you can just send ICP to its like cycles wallet or something like that, and then converts the cycles and tops it up. So in Stoic Wallet, there's a little like battery in the bottom right. You can just click it, throw in a canister, top it up with cycles. So some people are thinking through like how can we collectively as a community get people to top up cycles and things like that. Retrieving ICP from Entrepot took days. Yes, so that's not related to IC slowness in most cases. Sometimes subnets get kind of slow. The finalization rate goes down. This is because some subnets are getting really, really big, tons of apps, tons of people on them. And so side note, if you're deploying a Cycles wallet, I think when you deploy a canister, it gives you which subnet it's on. If you get PJLJW, I would advise you to spin up a new Cycles wallet and get a different subnet. You don't have to, but Entrepot's on PJLJW, so I'm intimately familiar with its downtime, and it's not as good as the other subnets. So that's my sneak peek hint for you all. Let's see. So retrieving ICP, that's just because of some Entrepot issues that we're working through right now. We almost have it all fixed, but still have a few legacy issues. How does backend work? DBs, MySQL, MongoDB storing user data. I see backend. Okay, so let's talk about backend. So when you have Motoko file running on a canister, basically everything's in memory. So you don't really have a database. You don't really have. It's just all in memory. So you have an object, and you just store stuff in the object, and then it's persisted, and so you can access everything in memory essentially. I think there is something like, what is it, like stable storage or something, but generally, yeah, no database that you're like making requests to. Everything is just in memory. Could you transfer cycles from one canister to another? I don't know. I don't think so. I think once cycles are on a canister, yeah, in fact, I'm pretty sure you cannot. Once you've topped up a canister with cycles, they're just on there for good. So in fact, we ran into an issue where there's a thing called a heartbeat function, and it like actually like runs. It's like cron. It's like a cron, but it's on the internet computer. It's the heartbeat. And we had it executing something, and it just kept failing. And the heartbeat kept calling it, and it kept failing. And so it kept retrying and kept failing. And we didn't have a way for it to fail gracefully. So it got caught in this annoying loop. And the loop just basically, like, the canister was not very usable because we couldn't get rid of the cycles. We couldn't transfer them. We couldn't do anything. And so we just had to wait for cycles to deplete until it reached like the bare minimum, at which point we could actually, like, that process stopped and we could go in. So we actually have like an admin kill heartbeat function now. So if you use heartbeat, be sure to have a way that you can call the canister and stop the heartbeat from running so that you don't get like heartbeat infinite loop stuff. Some projects having their own subnet. That's interesting. I don't know if that's true. I know there were verified subnets and there were unverified subnets, but then they decided to basically merge them. So they were all verified. I don't know if they've done that yet, but it was cheaper to create canisters on a verified subnet. And I know that some things like maybe the NNS, I know it's on a subnet of like 32 or 33. And so that might have its own unique subnet. Eventually we'll have all different kinds of subnets, like storage subnets, compute subnets, with not very many nodes or tons of nodes, depending on how much speed you want or how much security you want. But right now, basically just a whole bunch of random 13 node subnets. Yeah, Heartbeat isn't going to work with DFX 8.4. I think you're going to need to go to DFX 9.2 in order to get Heartbeat functionality in Motoko. I believe that's the case. I've seen other people have that exact same error, and they had to go to 9.2. And then there were a few other weird things that they had to do, but yeah. Yeah, it depends on your wallet. Whatever subnet your wallet gets deployed to, that's where your canister is. So if you don't like a subnet, create a new wallet and hope to get a different subnet. Yep, that's exactly the case. So you can just, if you wanted to, spin up wallets, and then every wallet is going to have a different subnet, and then you can pick whatever subnet you want, or rotate between them, or spread out across subnets, or do whatever you want. Excellent questions, everyone. This has been super fun. Let's see, what else should let's go to, I wanted to show you guys something that Jorgen Builder built. Where should I go to do it? Maybe I'll go to Entrepot. Okay, let's go to the marketplace. Let me inspect. You'll notice over here that I have a Chrome extension. That's the Dfinity decoder. So let me come back to the marketplace. Let's see if it gives me any function calls. Oh yeah. Gives me a ton of function calls. Let me click into this specific. Sorry, just rearranging some of the boxes I have up. Basically gives you all sorts of nice stuff, like which canister was called, was it a query or an update, gives you a timestamp. You can click in and you can actually see it was a query, what was the host, what was the canister, what was the method, the payload, specifically what were the arguments that were passed. In this case, this looks like a token ID, who the caller is. This looks like the anonymous caller. So, not authenticated, and then also gives me response. Let's see, where can I find this Jorgen Builder? Here's his GitHub, Chrome Dfinity decoder. Let me paste this in the chat. Okay, there's Jorgen Builder extension. Basically really nice. You can go to really any app and you can just explore and you can see what kind of functions are called. So let's check out district. Let me get a clean slate here. I'm going to have to log in with my internet identity. This is internet identity. If you're not familiar with internet identity, it's a way that you can authenticate with applications. I just touched my fingerprint on my computer. And so now with that anchor number and my fingerprint, I'm now logging into district. And that's all you need. I don't even need a wallet. I just need my fingerprint, and it's going to give me a unique identity that's based on this specific URL. And my fingerprint, essentially. Jorgen Builder is like a Motoko OG. Motoko's only been around for a little while. Mainnet's only been around since May, but he was like the very beginning. He's probably like a top 5 in the world Motoko dev. Partly because there aren't that many Motoko devs, but partly because he's absolutely amazing. Okay, so you can see district making tons and tons and tons of requests in here. We can make a post. We could look at the queries and things like that. Okay, we had some requests. Do you want to go over Bob NFT at a high level as that's provided as a reference for the NFT minting project? Yes, I would love to do that. Let's do it. How are we doing time? Time-wise, we're doing okay. All right, let's jump into bobnfts.com. So this is that was just a URL. It redirects to the canister. So canister deployed here. You can see, let me just sign out. Okay, so the way Bob NFTs works is you sign in. So this is just using Stoic Identity. Stoic Identity is just the way to do wallet sign in. So you click sign in, it's going to actually log into, oh, you're going to like see stuff that's like recorded. Oh, well, that's been immortalized in time now. Okay, so then you're logged in, and some of the requests that I'm making now, like this identity is actually going to be passed into the actor, so I can actually make authenticated requests. So Bob NFTs, the way it works is these are NFT gated communities. So this is the public. You don't actually need any NFTs to see the public message. Here is the community. You actually need one NFT to see the community method. For supporters, you need 10 NFTs to see the supporter message. Believers, you need 25 NFTs. And for the champions, you can see here, I don't have enough NFTs myself to be a champion yet. I need to mint myself some more Bob NFTs. So that's how the NFT gating works. It's basically gated content based on different levels of NFT ownership, which is cool. You can see here, I can actually browse my NFTs. So you can see all the NFTs I own. This is basically just making a request to the Bob NFT canister, and then it's just pulling down all the NFTs that I own. I can even just click one, and you can see in the URL, we have a canister. So this is the Bob NFT canister, and then we have a token ID, and then it'll just display it. So now let's go back. Let me show you the mint. Well, actually, let's actually mint a Bob NFT right here. I'm going to need to find one of my, let's grab my latest tweet because likely no one has minted it yet. Oh yeah, paid promotion one, that was a good one. Okay, let's get the tweet link. I'm embarrassed that I just complimented myself on video. Okay, we drop in a content URL. Let's give it a party and content snippet. I actually want to just paste in the contents of the tweet. So let's just come in here, copy it all. Sorry, the bar keeps showing up at the top. Okay, content snippet. I think emojis are supported. I click get price. It's going to load the price. Price always starts at 0.3 and then it doubles every time. Don't you dare, Jesse. Okay, so price 0.3. And then I just click purchase. So what's going to happen is first, it's going to go make an ICP transfer. Because I'm already authenticated with my wallet, it can just make a signed transfer. So it's calling the ledger canister, the global ICP ledger canister. I think it's just hard coded in the code base because it's just the one ledger canister. So it makes the transfer and then it gets back a block index. When it gets the block index, then it sends the block index to the back end, and the back end says, oh, good, we got a block index. So then there's a Rust. So there's a Motoko backend that actually gets the block index. Then there's a Rust canister. You need the Rust canister to actually, I think it's the protobuf API for the ledger. It's like the only way to actually retrieve a block. I don't think there's a way to retrieve a block on the Motoko side yet. So we have this little Rust canister created by Quint, Aviate Labs. If you haven't seen, this is another excellent repo that you should go to. Hold on, let me find it. Aviate Labs right here. You can see 30 plus Motoko packages and libraries. So if you haven't seen this, then you should. Motoko uses protobufs. Can we use Java to query? I don't know the answer to that. I just know that Quint built a Rust canister and the Rust canister does it. And so that's what we used. So if you see like a Rust canister code in there, that's essentially what it's doing. Taking the block index that was passed from the front end, goes and checks the ledger, retrieves the contents of the block, and then passes it back to the Motoko backend that then now has the block contents as well as what was sent from the front end and says, did the right person actually do this? Was it the correct price? What did they mint? And then it will actually mint the NFT and pass the NFT, transfer the NFT to the owner. And so, yeah, so that's how it works. That's how the ICP transfer works. It's a pretty safe method, except that if the ICP transfer is successful and then the mint fails, then you have now paid ICP and you have not received an NFT. So we have, a refund system in place for that. But I think there are ways you could use local storage to kind of store ICP transactions that have occurred that have not yet been sent up to the back end as a potential fix for that. So that's how Bob NFTs work. Let's see, I'm missing a few questions. I've heard there's a secret in the borders. What is it? Yes, there's a secret and no hints have been given yet, but there is a secret in there. NFT version of Patreon, that's a great way to think about it. Arbitrage opportunity needs to be said more often than that one time. Motoko uses protobufs. Let's see, Motoko uses Candid. IC internal uses for some internal implementations. Cool. Yeah, so there might be a different way to do it. We just use the existing Rust canister to do it so that we didn't have to come up with our own implementation. So this is the gist of Bob NFTs. NFT gated content, anyone can come in and mint. Log in with Stoic using Stoic identity. I don't know, maybe I'll pop up a Stoic identity. This is probably the best simple Stoic identity example out there right now. Just a simple way to implement Stoic identity. And yeah, I mean, any other questions on, that's essentially what the Bob NFT repo is. Ooh, interactive hand raising. I mean, you've been just so active on the comments. Like I haven't even needed to like ping you all on the hand raising. Bob NFT is available on GitHub. There is, yes. Let's see. There's a creator NFT repo here that should be public. It is public. Okay, dropping it in here. So this is the open source version of Bob NFTs. Essentially, we took this version and implemented a little bit of custom stuff for Bob NFTs. And so this is the kind of public repo that I think we passed along. So we do handle ICP transfer. We do handle NFT minting. We do some SVG image stacking. You'll notice if you look at a Bob NFT, hold on, let me pull one up. You'll notice that we have the text here, we have the URL here, we have the flare down in the bottom right, and then we have the border. So these are essentially just SVGs all stacked on top of each other. And so that's how we handled kind of our generative mint process, because all of these are custom info, and then you're randomly given a border. And some borders are more rare than others, some are more common. What is anonymous account? I found anonymous identity on my local besides default. Yeah, so you can make you can call any canister with the anonymous principal. And sometimes that's totally fine. It depends on how the method has been configured. Sometimes you actually have to call it with an authorized identity. But in other cases, I mean, methods are just public. So for example, one thing I haven't shown you at all that I wanted to before we go, I wanted to show you, maybe you've seen IC Rocks already. Poke Studio, why are you not loading right now? There we go. Okay, so if you go to any NFT and you open image in new tab, then you get, like I said before, you get a canister ID, and then you get a token ID. If you go to IC Rocks, you can paste in a canister and you actually get the canister interface. So here are all of the methods that I can call on the poked bots canister. So for example, this is the admin kill heartbeat that I was talking about earlier. So only admin can call it, and it's just to stop any kind of heartbeat loop. And then also to start. If we scroll down, you can see available cycles. This is just a public method. Anyone can come in here and query. It's just going to give me an update on cycles. There is another get registry is one. So public method, I'm actually calling with the anonymous principal. See, it returns raw, but I can just turn to JSON. Now it gives me every token and the owner of the token. And so you don't actually need to be authenticated in order to run the get registry call. So you just do it with the anonymous principal. Let's see. Is there any difference with Stoic identity and the Definity's identity? I'm assuming by Definity's identity, you mean the internet identity. And yes, they are completely different. Internet identity doesn't have a wallet baked in, so you can't actually own NFTs in an internet identity wallet. I mean, the principal could own it, but you have no way to interact with it. So Stoic Wallet and Plug Wallet are the two biggest wallets used for NFTs. Internet identity is used for apps that don't really need NFT access, because currently there's no wallet for internet identity. You have a GitHub example of a canister that stores complex data and structures. What could I share? I don't know the answer to that. I might have one, so let me look. And if I have one, I'll share. Okay. That's pretty good. I mean, we've talked to like ICP big picture, talked about a lot of the tools I use, talked about NFTs and kind of back end. Any other questions while we're here? I think we still have a couple minutes for questions. I'm happy to answer any of them. I mean, I know we've kind of been doing it along the way, which is how I preferred. Process of submitting NFTs to Entropy. Yeah, I think we need to change the name of Entropot. Entropot. IC Rocks partially doesn't work because the developer that built it, he did a really good job, but didn't really want to sustain it long term. So lots of stuff is broken, and now it kind of doesn't work. So if you want to look at like transaction information, you can just go to dashboard.internetcomputer.org. You can do it here. You can search for a transaction or for a canister or an account number. You can't search for principals, which is too bad, but you can search for principals in IC Rocks. So the way that I usually do it is I search for a principal here, and then it will give me the account address, and then I'll come over here and I'll search for the account address. So that's generally my process there. Submitting a NFT project to Entrepot. So right now there's a set of marketplace methods. Basically, you implement the EXT standard, the non-fungible extension, and then you have all of the code that you need for your NFT canister. Then you also need a set of marketplace methods. Just for historical reasons, we haven't open sourced that yet, but it will be open source soon. So you get the marketplace methods from me, you add those on to your canister, and then you're all good to go. You say, hey, I have an EXT canister, and then you add me to your repo, and we just review it to make sure you're not gonna like steal NFTs or you like hacked some function to take stuff from people. And then once it's all good, then we just have a whitelist process. We have like a form you fill out, like you have to have like a name for your collection and some images. So you fill out the form, and then we just take all of those. We have everything, we set it all up, and we whitelist. And that's how projects are added. Let's see. What are security measures to take during development while launching project on the IC? Let's see. I mean, the IC really does a good job of handling almost everything. You need to be a little bit more careful when you're dealing with wallets and when you're dealing with people's ICP and when you're dealing with their NFTs, because now you actually have value that you have to be careful about. So anytime you're minting or you're burning or you're transferring or you're handling ICP, you just need to be a little bit more careful. So there's lots of code out there that does these kinds of things now. So I would use an existing implementation if you can find it, and or just do everything on test canisters to start, play around, make sure you can do things without breaking anything. How much does it cost to run Entrepot and cycle fees? Well, it used to be really, really cheap. And then we implemented this complicated heartbeat cron system to do ICP and canisters. And now we're burning like 1 trillion cycles per day per canister, which is only $1.40 per day per canister. We have like 65 canisters. So that puts us up to like $100 a day, which is like $36,000 a year. Obviously, that's way too much. So we're going to scale it back. Before it was like, I don't know, I could mint 10,000 NFTs and facilitate a month's worth of transactions. And it was like $3 or something like that. So very, very cheap. We have some inefficient stuff happening right now. So cost is a little high, but we're bringing that back down. Can we encrypt the data stored in a canister so the nodes wouldn't be able to see the data? Yeah, if you wanted to implement your own kind of encryption on your data, I think that's totally possible. And for very, very secure data, yeah, I think that's probably a good way to go. In some cases, if you log in with internet identity, you don't even really have any secure data. Like, who cares if people steal it? So think about like Discover. Discover is all public. You can see all the posts, and you just log in with internet identity and you just have a principal. And so you're not storing names, you're not storing IP address, you're not storing credit card information. It's just a principal. So, I mean, there isn't really any data to be concerned about because it's either all public. Yeah, it's all public anyway. So from that perspective, not as big of a deal, but there's definitely data that could be sensitive. Let's see, if you know what you know now, would you do certain Entrepot architecture tech differently? That's a really good question. I mean, Entrepot is like, small startup that's growing faster than it can handle. And so you're just going to run into problems along the way. So one of the things we're running into right now is we have 65 NFT canisters. If I want to know which NFT you own, I actually have to go and I have to ping every single canister and I have to check if you own any NFTs. And so once we have 100 or 500 or 1,000 NFT canisters, that's going to take a really long time. And so we're working on implementing kind of a middleman API where the API goes and queries everything at a good kind of cadence. And then the front end is actually just going to hit the API once with the query. It's going to say, give me all the NFTs for this person. Similarly, I think CAP might be doing something like that. Psychedelic is the group that developed CAP, Certified Asset Provenance. We just implemented CAP on all of our canisters. Basically just tracks all transactions, transfers, et cetera, has really good provenance for NFTs. So I think they're trying to do something like that as well. So that was kind of not really an answer to your question, but feel free to hit me up on Twitter or wherever, and we can talk more about that. How did you test Bob NFT application before mainnet deployment? Can NFT mints and sales be mimicked on local deployment somehow? I think they can be mimicked on local deployment. I think you can spin up local canisters, NFT canisters, et cetera, and you can test everything locally. ICP is a little bit harder because you actually have to implement in a local ICP ledger. I think people have done it before, but it feels a little bit annoying. Alternatively, the way we tested, I mean, you can do local testing, but we just pushed to production, and then you can whitelist specific principals. So, we push to production and we have a login button, and only, admin principals can access the site. So then I log in, and then we can test everything we want in production. And then once we're done doing all our testing, we essentially just wipe the canister and start it up clean. And then we're certain that, yes, it worked locally, but is it going to work on the mainnet? Sometimes things work locally and they don't work on the mainnet. So it's probably a good idea to whitelist principals first on the mainnet. You can have people go in and test and do everything and mess up whatever. And then once you're certain it's good, then, you can just wipe it and then relinquish your principal restriction, and then you should be pretty good for deployment. How do my HTTP requests get to an ICP subnet? I believe that when you make a request, it actually goes to the boundary node. There are like 4 or maybe 6 now boundary nodes, maybe 10. I don't know the number, but your request gets routed to the boundary node. The boundary node then says, hey, where's the canister? Which canister are you trying to hit? And then it routes your traffic that way. And so I believe all requests, you'll notice it's like canister.ic0.app. And so it's basically a domain, ic0.app, and a subdomain, which is the canister. And so all traffic gets routed to boundary nodes, then boundary nodes handle it all and then shoot you off into the appropriate place. When Bob coin, man, I want to release a Bob coin so bad. It's going to be amazing. Just wait till you can stake your Bob NFTs and earn Bob coin. I think I'm actually going to do some cool NFT partnerships with other projects where, I'll hide something, and if you find it, then you can like claim Bob token. It's going to be cool. What is your view on all the different standards for NFTs and tokens? Will this get standardized soon? Man, that is a really good question. Currently, there are a whole bunch of NFT standards, EXT and DIP 721, and there's the Punk standard, and there's, I think, the Bunny standard, and there's like 3 or 4 others that I haven't mentioned. And so you have a whole bunch of different kinds of NFT standard, which is kind of annoying. We're getting to the point where it's starting to be a little bit painful. We definitely need to standardize around something, but I mean, it's still early days. People are just building and they want to move fast, and it's easy to just do your own standard because it fits your, your past experience and the way you want to build. And so I think that we do need standardization, and we're not there yet. Dfinity came out with a fungible token ledger. I think that's going to be the basis for a fungible token standard. And I think it'll be relatively simple to all, build on top of the Dfinity supported ledger for fungible tokens. For non-fungible tokens, NFTs, it's a little harder because how can you standardize? And an NFT is basically like a row of data, and the row, I mean, you're just saving it in a canister. And so anything could be an NFT. It could be a piece of code. It could be an image. It could be a piece of audio. It could be a video. It could be a document. It could be a PDF. It could be anything. It could be another NFT. It could be a basket of NFTs. So anything, any digital piece of data could be an NFT. So how in the world are you going to standardize methods to access, interact with all of the data in the world? Like, it's just not going to happen. So I think what we need is, I think EXT is the right idea, where we want an extendable or extensible token standard, but also something like DIP 721 has the right idea, where we want something that's similar to what we have on Ethereum. And so I think there might be some kind of like mashup we could do in the future, where you have something that's very simple, easy to implement, well documented, that is then extendable into different kinds of data types. Maybe there's a blog post NFT standard. Maybe there's a music file NFT standard. And so you could imagine all these different data types all having different kinds of extensions, but standardizing around them is extremely powerful. We don't have to dig into the whole thing there, but yeah, that's a little bit about it. Bobcoin plus OG metal, yes. Boundary node, reverse proxy. I'll just trust you on that one. I maybe missed something in my explanation. EXT is greater than DIP 721. I mean, yeah, we use EXT everywhere, but some people like the simplicity of the DIP 721 standard. What's the purpose of wrapping NFTs? Okay, so wrapping NFTs for Entrepot, we have methods implemented. We haven't namespaced our methods yet, which is something we need to do. But basically, we just have a set of methods. If you implement the methods and they're the same, you can just whitelist on Entrepot, and it's really easy. If you have a different kind of standard, then essentially you have to like remap the functions. So wait, is that how? I think we actually create a new canister. So you have your existing NFT canister. I think we have a wrapped NFT canister. So when you wrap it, it's almost like bridging an NFT. You basically transfer your NFT from yourself to the wrapper canister, and the wrapper canister is then able to do things for you on the existing canister. So when you wrap an NFT, it's basically send it to the wrapper. Now the wrapper owns the NFT and can do whatever it wants with it, but then essentially you can do things on the existing canister, like transfer, like ownership and things like that. So it's like bridging, essentially. That's how wrapping works. Purpose of wrapping is so you can support other standards. So like the Punk standard by default isn't supported on Entrepot, doesn't have the right methods, but we have a Punks canister, we have a wrapped Punks canister. So you transfer your Punk to the wrapped canister, and then we can now interface with the existing Punks canister from Entrepot and have other kinds of methods. Where's the metadata standard defined? I found Motoko interfaces. Can't find the JSON standard for metadata. Metadata is not really defined that well. I think it's just a blob right now. The way that metadata works, we use it sometimes for our generative collections. So when you do a generative mint, you have a bunch of trait categories: body, head, hand, hair, necklace, whatever. And so the metadata is actually just an array indicating which asset should be displayed for each NFT. So it might say like 05432. That means the 0th body and the 5th head and the 4th hand, etc. You can do JSON. I think you just have to essentially encode it appropriately, and then you can throw it in. So I know like the Punk standard uses JSON in their metadata. I know a few other standards that do as well. I don't know that JSON is like natively supported with EXT, but it feels like it probably should eventually. Is there Rust code for EXT implementation as well? I believe the answer is no. No Rust EXT implementation yet that I know of. So it's all Motoko at this point, 100% Motoko. If someone wants to implement a Rust version, I would love that, and I can probably throw some money your way as well. But tell me before you build it, just in case you do it, and it's, yeah, just so we're aware and can help you out in the process. Any idea on logging to IC Internet Computer using Linux device login details, just like Windows Hello? That's a tricky internet identity question. My default guess is not supported. Obviously, you can use something like YubiKey. YubiKey gets you in, so you could probably just plug it in. That would work for a Linux device. I don't know if there's anything like Fingerprint or Windows Hello or code or anything like that on Linux. I think I remember a forum topic on it, but I don't have a Linux device, so I haven't worried about. It's not the same as Solana ETH. I don't know the context for that question. Crypto is good, but happy to tackle it. If DNS servers went down, how would ICP stay accessible? If the boundary nodes went down, it would not be accessible. Boundary nodes, let's see, DNS servers. Well, I mean, if boundary nodes went down, obviously inaccessible. If nodes went down, all the nodes in a subnet, then inaccessible. If DNS servers went down, that's a good question. I think Dfinity had a plan to have a decentralized DNS, but not yet. And so if DNS servers went down, I don't know, maybe it's inaccessible. That could be a central point of failure right now. I don't know exactly though, but that's my best guess. These are all excellent questions. To identity, not the same one as Solana ETH. Yeah, I mean, I'm happy to answer it. I'm still not quite following. If you can like rephrase, then I'm happy to tackle it. Let's see. I think we're a bit over time, but this has been really fun. I mean, I'm happy to stay on and answer questions if anyone still has questions.
Yeah, we've been here for over 70 minutes now.
Yeah.
Do you want to take some more questions, Bob? That's up to you.
Oh, I'm totally fine to hang out. This is really fun. I see
So
some projects.
do you want to open the mic for participants, or you prefer just to read the questions and respond?
Oh, I mean, reading questions is totally fine.
Okay.
Kind of streamlines things. Yeah, so you can get a custom domain, and I think the way you do it, I actually saved because I knew this question would come up. Where is my, here it is, custom URL front end. Okay, this is the repo that some people have used. I don't think it's completely decentralized right now, but it does. It's like a reverse proxy that lets you use your own domain. Yeah. So this is probably the best way to get your own kind of nice domain name rather than the really long one. What do you think about BTC integration? Yeah, so BTC integration is going to be really nice because you can just go into like your Stoic wallet and you can have a BTC address. And so you can just send Bitcoin directly to your Stoic wallet. And then we could have collections in Entrepot that are listed in BTC. And when you buy, essentially, we can facilitate that transaction directly from the IC. It's like the internet computer is acting as like a Bitcoin node, kind of, is the way I understand it. And so I think BTC integration is going to be awesome. Same with the Ethereum integration. I'm a little bit more excited about the Ethereum integration than I am about the Bitcoin integration, just because Ethereum has so many network effects. People building things on Ethereum, people using Ethereum for NFTs, people using Ethereum for DeFi. There's so much going on top of Ethereum that I think the ETH integration is going to be bigger than the Bitcoin integration. Also, BTC maxis tend to love Bitcoin the most, and I don't know if they'll be accepting of something like the internet computer. So we may not see any crazy activity. I mean, this is like wild speculation on my point, on my part, but we might not see any crazy things happen from the BTC integration. But I think definitely from the Ethereum integration, I think we'll see some synergies, I guess I'll say. Will the .icp domains remain in auction, or will there be a direct buy option like ENS? Yeah, so I mean, the name service is a little bit tricky because I don't think .icp is actually a valid TLD. And so you can't have like bob.icp like go there in your browser, at least not yet. There might be ways to do like .icp.host or like .ic0.app or something like that. And it really depends on who people decide to support. I mean, a name service is basically just address to human readable name mapping. And so anyone could spin one up. Like I could just spin up a name service right now and auction off .icp names, and maybe Stoic Wallet could support it, and then it could get more traction. So it's basically whoever the community decides is the winner, which on Ethereum is ENS. And I know they do auctions for lower character names because they're just in higher demand, but then longer ones are kind of, you can just go in and buy it. So that's BTC maxis are evil. It is basically using a centralized service to serve your service worker that acts as a proxy sitting on your browser. So you see the nice URLs, but you're still talking to the IC. Yeah. Yeah. So it's not completely decentralized yet because you have the centralized service that serves you the service worker. Yep. But someday I think we'll have a decentralized version. What I was saying is the Solana ETH, the NFT URL returns a JSON file, then the JSON file is a property for image. Yeah, so you could do that same kind of thing with metadata. But yeah, with like an Ethereum or Solana NFT, you basically have image URL and you have JSON or metadata URL, and it's not, at least from what I've seen of EXT so far, it's not as natively integrated in EXT as it is with like an ERC 721. But again, like I said, probably deserves to be first-class citizen in an NFT standard attributes. So yeah. Isn't it true that ICP to the moon? Potentially, yeah. ICP has a chance to be essentially the next big blockchain. Like it could host the web of the future. It could be the AWS of the future. Maybe it also suffers from some crazy scalability or security flaw. Like maybe you can't get private data in a good way or in an easy way. And maybe it has some specific use case, like, anything that needs to be web speed goes on the IC, but anything that needs to be really secure needs to go on Ethereum or something like that. I don't know what the future of ICP holds, but I'm obviously extremely bullish building a company on it, as well as, putting money into ICP and helping with governance. So definitely very bullish on ICP. Seems like most activity on the IC is about NFTs, but it could do so much more in a deal where there aren't already thousands of high-powered developers implementing all sorts of things on the IC. Yeah, that's a great question. Question is basically, why aren't people doing more? Partly because of the launch dynamics, got kind of a bad reputation. The Dfinity Foundation hasn't been the best at marketing to non-technical people, to developers from other blockchains. So kind of a host of reasons, but it's definitely picking up. They're doing hackathons, they're doing grants. They have many, many grant recipients. More and more developers are coming in. And so I think we just need time until we have, thousands of awesome developers implementing amazing things. I think it's just time. Especially once ICP has its Solana moment, I would say, air quotes. That's basically when, I don't know, you get tons of DeFi activity or something, and then, price spikes. Solana basically went up to like 150 or something like that. And so with that kind of Solana moment, you also get tons of traction, tons of eyes, tons of devs. Let's see, criteria of accepting new NFT projects on Entrepot. Unfortunately, right now, Entrepot is kind of being a gatekeeper. That's because there are tons of projects and we can't support everyone. So we have to make some kind of determination. We're trying to remove ourselves as gatekeepers as quickly as possible, meaning anyone can just go in. We have a self-minting kind of platform that we're coming out with. And so anyone can just go in, upload their assets, pick their launch details, and then just launch an NFT. And so that effectively removes us as gatekeepers, lets anyone kind of, list their NFTs on Entrepot, and that would be a really nice kind of scenario. So right now, we look at who does the community like and who does the community support. And we look at like social followings, and we look at quality of art, and we look at what the project's doing. And that's essentially how we're evaluating NFT projects on Entrepot. How do we protect from scams? Under human readable address, you receive a scam canister copy where you are in trouble. Yeah, we haven't seen very many scams on the IC, but I could implement a new website. I could call it district with 2 eyes or 3 eyes .app. and people might not notice, and they'll just like type it in or click on a link, and it'll go to a fake district, and then I could like, do nefarious things. I can make them log in with the wallet and sign transactions and give me their NFTs or their ICP. And so, I mean, I think scams is a serious concern that we haven't really faced that much on the IC yet. Like, as far as I know, no one's been scammed out of mass ICP or NFTs, but it's likely coming. And so we need to, be careful and be vigilant as users. I don't know exactly, I don't know if there's a silver bullet for scam protection. What do you think of the Infura and consensus drama with JPM? Seems like there's not a better timing with the integrations coming up. Yeah, so if you look at US law, there are sanctions concerns for US companies. And if you don't comply with sanctions, and I mean, you can just go to jail, because the US imposes sanctions on countries. It's basically like financial warfare almost. You put restrictions, you can't interact with people from Iran for, XYZ. So it's hard because there are decentralization maximalists who want essentially a permissionless, rule-less future. And then there's, existing regulation moving slowly. There's existing government systems. And I find myself kind of in the middle where I kind of want to compromise. I don't know that going fully decentralized anonymous, you can do whatever you want. Essentially, there's no law. You have no copyright protection. You have, I'm not sure that's the version of the future that I want. But at the same time, I don't want the heavily regulated, basically you can't do anything kind of side of things. And so, in the middle somewhere, I think there's a happy medium where we can have regulation that is crypto friendly and supportive of decentralized applications and what's happening there. Basically, I mean, if you look at sanctions law, it's concerning and interesting to think about in the context of, where you sit along the continuum. I won't go too much deeper there. Let's see. Yeah, so custody into cold wallets is a really good scam protection method. So basically, there's a way to degenerating into a Twitch stream. I mean, it is being recorded. I mean, and anyone can come and watch it. I don't know if it's degenerating into a Twitch stream. It feels like we're elevating into a higher level here. So ascending into a Twitch stream, maybe. But self-custody into cold wallet is a really good way to go. Basically have all of your, the majority of your assets and important things in a wallet that you don't regularly use. Cold wallet, even better. And then have your hot wallet, or the wallet you interact with and interact with apps on, that can be, have fewer assets, and it's less of a concern if you get hacked. I mean, that's a really good way to protect your assets. Let's see. Other than ICP, any coins blockchain protocols are you inserted in? So I really like Ethereum. Ethereum and ICP are probably my favorites. Ethereum because it's just, I mean, the network effects on Ethereum are crazy. Like, everyone uses MetaMask and Ethereum. There are some other ones, Solana, Avalanche, Near, Terra Luna, etc. But Ethereum has some really exciting things coming this year, like the move to proof of stake, as well as rollups. Zero knowledge rollups. Basically, we're going to get like 100x reduction, 100x plus reduction in gas fees. So now you can do things on Ethereum really cheaply. And so I think volume is going to go way up. Those things are going to happen this year. And so really like Ethereum and really like ICP right now. So I'm also very deep on the ETH side, NFTs, other kinds of token projects. partly to get more experience, partly because there are some really big universe type NFT projects, basically creating their own kind of IP universe. So I'm learning from the people over there, and then trying to translate, like, how can we do things like that, but better on the internet computer. So do you have any familiarity with the origin standard? Nothing at all. I think I may have seen something about it once, but no, never seen an NFT minted using the origin standard. And I don't think I've ever seen a canister there either. List of all of their active bounties. Do we have an origin one in here? Yeah, I don't see it. Bounty 17. Let's see. Description. Create a DAO. Cycles. Yeah. Yeah. Origin. The canister should support calling DIP 20, EXT fungible on ledgers, and DIP 721, EXT non-fungible on the NFT origin standard for NFTs. Yeah, there it is. Mint. Yeah, I know nothing. I know nothing about the NFT origin standard. Are there things you see ETH being better for than the IC now, 5 years from now? I mean, if you're looking for security, just straight up, and decentralization, I mean, you're probably going to pick Ethereum right now. If you're going to transfer like $5 billion and you don't want it to get hacked, Ethereum with thousands of nodes, being more decentralized, consensus across all nodes. I mean, it's probably the gold standard for security right now. So some people see Ethereum as like kind of a settlement layer, where a global settlement layer, where if you really need something secure, you can do it on Ethereum. That's definitely true right now. But I think that the internet computer could be all of those things eventually. I think that we'll see in the future that people care less about which chain they're on, and just that it's functional and handles a use case. So, you know, whatever is easiest to use and cheapest and fastest, then you're going to use it, because why would you use anything else? So if the internet computer can be the fastest and the most secure and the cheapest, then I don't see why you would use anything else to do anything. Again, maybe there are some side use cases like ultimate maximum security on Ethereum or something like that. Or maybe the internet computer doesn't really handle, I don't know, massive multiplayer games very well because of canister latency or something like that. And so there's a chance that certain use cases are better served from other places, but there's a chance that you can just do everything on the IC in the future. What do I think of Chainlink? I mean, Chainlink is like the ultimate Oracle solution, right? And so definitely they're doing a really good thing for the blockchain world. There's a chance that the internet computer can just do the same thing as Chainlink, but much simply, much more in a much more simple fashion. Once we can do HTTP requests, then you just have a canister. It's going to make like 30 API calls, bring all the data in, and then you're going to, you know, use whatever method to, like, let's say you grab Ethereum price, you're going to do something to get kind of like a standard price. And then, I mean, that's essentially your Oracle on the internet computer. Black hole that canister. And I mean, Chainlink does other things as well. I think Jordan Last had a thread where he was bantering with some Chainlink people. So I think the internet computer could do what Chainlink is doing in a more simple way, but still TBD. I mean, we don't even have HTTP requests yet. What is the difference between on-chain and cloud? I find it difficult to explain. Yeah, I mean, if you have something on chain, then it's decentralized. And so you have the benefits of decentralization. So think about like the downsides of centralization. Like if it's just on cloud, let's say it's AWS or it's Google Cloud or it's Microsoft Azure. If you have data stored on cloud, then you have a centralized data provider. And so you have all the downsides of centralization, like platform risk and not having a say in what happens in the future. And you have a big tech titan that's trying to essentially capitalize on profits. And you don't have any kind of community governance. You don't have any kind of community ownership. And so all the downsides of centralization when you go on cloud, when you go on chain, depending on what chain you go on, you get the benefits of decentralization, community ownership, things like that. I have a few Web3 articles coming out on that kind of thing. I don't quite have them out yet, though. Everyone's asking about their bags now. Do you know of any other projects that could potentially let you build secure web speed apps? Yeah, I mean, Solana is a good example. Solana, I think my main concern with Solana is there is a max transactions per second that is kind of, so it's proof of work, but more novel with proof of history. Based on my understanding, there's a max transactions per second that you can't really get around right now. And so it's not infinitely scalable. Like on the internet computer, you just spin up more subnets, and the more subnets you have, the more you can scale. But on Solana, it's not quite that simple. So but for Solana right now, as long as it doesn't get too big, I mean, I think it's perfectly fine. Like you can build good applications on it. Avalanche is another good one. Avalanche does have a subnet architecture, which is interesting, similar to the um, internet computer, but for their subnets, I believe you have to get new people supporting the subnet, essentially getting your own nodes to support the subnet. Plus, you have to issue your own token and get people to like support the token. So spinning up subnets on Avalanche is a little bit annoying based on what I know right now, which may or may not be completely accurate. So those are a few other options. I think the internet computer is positioned to be a pretty strong leader for web speed dapps. Any pain points about Motoko? Yeah, pain points. Motoko is a new language. You notice that AV8 Labs has like 30 Motoko libraries, and he wrote all of those because they didn't exist. And so you're not going to get you're not going to find really super awesome documentation across everything. You're not going to find stuff on Stack Overflow. You're going to have some libraries that are not missing or things like that. So, and there are a few like gotchas just scattered around documentation places. So that's kind of, those are the kind of the pain points on the Motoko side. But I've heard really good things about building with Motoko. How do you write code without Stack Overflow? I know you might actually have to like write it or like write a letter to a friend and ask them to send you their code. What do you think about ADAs one transaction per second? Yeah, I don't know that I really want to talk about Cardano, but lots of hype and anticipation for something that may or may not ever materialize. Anyway, uh, yeah, I mean, I've kept you all. I've kept you all a long time. If you have more questions, I mean, I'm happy to answer them. You can ping me on Twitter, it's just at Bob Bodily. Let me actually just drop you my Twitter link. Where did I go? Feel free to DM me. Also, just generally, I mean, Tonic Labs is regularly looking for more devs. We're in a pretty good place right now, but likely hiring again here in the next month or two, or I mean, maybe even now. And so, I mean, you're all diving into the Motoko Bootcamp, so definitely keep that in mind. I mean, I'm happy to hear from you if that's at all interesting. Any other use cases for NFTs beyond art and access to certain portals on a site? Yeah, really quick. NFT use cases, they could be access tokens, like gating. They can also be art. They can also be voting tokens, so like governance. So one NFT equals one vote. Actually have like binding votes that could actually like govern a canister, like ownership of a canister. NFTs can be copyright licenses. So a Bob NFT is actually a CC BY license to my content. So when I minted that tweet as an NFT, I granted, I mean, I don't actually need the license because I am me, but all of my content is copyrighted. But if you mint an NFT of my content, you're granted a CC BY license and you can do whatever. So it could be a copyright license. NFTs can also be like a ticket to an event. It could be a piece of data like a driver's license or a government issued ID or date. It could be like a memory of like, a photo and whatever. So tons and tons of use cases. I actually have a really fun, if we go back to this homepage, my standard, I actually have to log out to this tweet. I talk about a whole bunch of really fun things you can do with NFTs. I clicked it. I didn't actually mean to click it. But yeah, lots of really fun things you can do with NFTs. I mean, basically, you're only limited by your own imagination because an NFT is just digital data. What range do you give to a Motoko dev? Yeah, I mean, totally depends. We have some Motoko devs that we pay, they're contractors, paying like $100 an hour. We have other Motoko devs that are less experienced or newer, and so also kind of depends on country, and so yeah, it ranges from like $30 an hour to $100 an hour, and just depends on experience and what you're willing to accept as a candidate. I mean, that's the really rough answer. Obviously can discuss more specifically. I don't need a license because, well, I'm me. Yeah, I should probably save that one. Maybe I'll tweet it out and someone can mint it as a Bob NFT.
Then we should wrap up end the meeting because it's been more than, I think, 90 minutes already.
Yeah. Yep. I mean, we're just having too much fun, Dukakis. So
yeah.
Thanks,
if you want to keep going, go ahead.
Oh no. I mean, this has been great. I mean, if anyone has questions, you can hit me up after. But this has been really fun.
Yeah, thank you very much, Bob. Myself, I enjoyed all the lecture, the introduction to the internet computer. So thank you for the support. I hope you guys enjoyed it. See you in a few hours for the next lecture. Bye, guys.
See you guys.